Hello, I'm Tom Hollingsworth, and this is Networking Field Day 13. We are here in sunny Silicon Valley, California, with SolarWinds. You are about to watch a presentation featuring SolarWinds and their unique solutions and products, along with a group of delegates around the table who represent the best and brightest in the networking industry. They have been invited to ask questions, make comments, and offer their opinion, and represent the networking community at large. If you would like to know more about Tech Field Day, including how to become a delegate or how to become a sponsor of this event, please go to our website at techfieldday.com. If you would like to see more videos like this about a wide range of technology subjects, please check out our YouTube channel at youtube.com/techfieldday.
Okay, so I'm Chris O'Brien. I'll be showing you some of the NetPath technology. We'll do a deep dive into how it works and how some people are using it and sort of what came of it after I showed it to you February this year, some time ago. So remember me from the presentation on NetPath in February. I'm currently working on Network Performance Monitor, which is the flagship product for SolarWinds. And I also work in the tech incubation team, the place where this NetPath technology came from. I'm a product manager. I have a network engineering background and I love networking, so feel free to ask me very technical questions. If you stump me, I'll just say I'm not smart enough. Interrupts encouraged. I can totally present for 2 hours, but I'd rather have a discussion, so feel free to interrupt. Let's jump right into it. So we'll be going over a couple of things today. We'll be focusing most of our time about NetPath. What is NetPath? To remind you, if you don't recall from last time, we'll map some of your paths live. So what that means is right now, start thinking about what are the services that you have available on the internet that you'd like to see what the network path looks like to. We will need the service name, whether it's IP or FQDN, plus the TCP port number. So start thinking about that. We'll map some of your paths live here. I'll show you some of the paths in NetPath. We'll do an update on our progress, sort of what's become of NetPath since it was a lab toy. And then we'll do a deep dive into how NetPath works, some of the technology we're really excited about. I love talking about the NetPath technology, so I'm excited for that part. Then also I'd like to get sort of give some thoughts on how we see network monitoring evolving and sort of open it up to a discussion on how you guys see network monitoring evolving. I think there's some interesting themes going on, and I think we're all working on doing better with our networks, and a piece of that is network monitoring. When I started as a network engineer, one of my first mentors taught me that monitoring was an essential part of building a good network. If you're going to run a network well, you need to do good monitoring. So that's sort of where my love of monitoring came from, and probably why I work at SolarWinds today. We'll then talk a little bit about network insight, what problem that's trying to solve, an example of how we've applied that sort of architecture of thinking about network monitoring for F5 load balancers, and talk about it as a framework. And I'll leave you with a parting question I'd like to get your input on. We have a disclaimer. This is usually the part where I tell you a joke about how legal requires us to put in a disclaimer, but I'll be more honest this time. I actually like this disclaimer, because what this disclaimer means to me is that SolarWinds, we try and talk about technology we have today and sell technology we have today, not try and sell you something we think we could possibly make. So I think that's a good thing. But what that means is anytime we talk about technology in the future, we have to say, remind you that these are our ideas, and the chances of us not doing it is pretty big, which is why when we presented before, it was a lab toy. We didn't know if NetPath would work out. So a quick 60-second or less introduction on SolarWinds is the vision for SolarWinds is to manage all things IT in a hybrid environment. So whether it's on premises or hosted, SaaS, cloud, any of these things, regardless of where the application, the infrastructure is, regardless of where we are deployed, we want to provide visibility that makes it easier to run a high-performing network and troubleshoot problems. Any questions? Okay. So what is NetPath? So if you think about how networking has evolved over the last 10 years, think back like 10 years ago, you had a network, it looked like this, at least if you had a marketing guy make a slide on it, it looked like this, right? You've got your multi-layer switch in the middle, you've got your little edge switches, your access switches, you've got access points, you may have a firewall, which looks very artistic here, I like that. And you've got all these endpoints connected to that, right? That was your world, this is my life, right? And you may have applications, hopefully you do have applications in your network, one of which being Exchange oftentimes, right? So that sits in your data center, you understand where it sits, you are responsible for the hardware, you have administrative access to all of this stuff, life is good, right? We have this thing called the internet, I hear. And we've seen this sort of proliferation of applications, so of SaaS applications. So we see applications like Exchange move over to the cloud and they change names and now they're Office 365. And that's not the only one, right? There's lots of these applications. Several of these SolarWinds uses themselves. We definitely use Salesforce and NetSuite and Tableau. And then there's a whole bunch of people that aren't supposed to use Dropbox but do, like me. So that's sort of how it's working now, is we're having this big shift in where these applications sit. You guys all know that. But traditional monitoring tools were really designed for that front end. They're designed with the assumption of administrative access. Okay? And that's a pretty big assumption. So when you try and monitor out into the internet, it really just doesn't work. We don't have great data on that. So NetPath's job is to drill down into that cloud and show you who are the companies involved, what is the performance they're providing, and how can you solve problems regardless of where the problem is in that application path from the user to the application. All right, so let's jump into a demo of NetPath. Okay, so this is just our public demo site. I use this site because it has data and because it's reliably available, unlike if I run my own server. I'm going to jump over, this is Orion, sort of our platform. I'm going to jump over to NPM, which is my product, and specifically the NetPath services screen. So this is going to list out for me all of the services that I'm monitoring, all of the destinations for my network paths. Does this make sense? And so I'm going to go ahead and jump into one of these. Salesforce is really important for SolarWinds.
Chris, is it possible for you to make that a little bigger?
I think so. How about that guy?
So old. Thank you.
Does that work? Okay. All right. So I'm going to jump into Salesforce, and I've sort of expanded this, and we can see I'm monitoring that from, in this case, one probe or one source, right? So the path is comprised of this Austin Lab probe, which is a software agent, over to Salesforce. So I'm going to click into that, and that will bring up the path for me. And for the sake of discussion, I'm going to get a lot of this other junk out of the way. We can look at this. Okay, so what are we seeing first? So to get yourself oriented to this picture, all the way on the extreme left-hand side, you can see the source of the path. Okay, so this is where I have the little software agent deployed. And this is all like sort of Google Map-esque with pan and zoom and all that sort of stuff. So this is where the agent is deployed. It has my name. I don't know why. I don't know why that is. I haven't noticed that before. But so this device is trying to reach www.salesforce.com, or precisely www.salesforce.com and port 80 in this case. Okay, and to reach that, it goes and transits through a bunch of network, some internet. We can see some companies here, and finally gets to the destination servers. Now in this case, Salesforce is providing content off of 2 servers. The bigger the site is, the more geographically dispersed they are. So Salesforce certainly has more than 2 servers, but in this case, that location that your users depend on is served from just those 2 servers. So that's the only thing you see here.
Now, is this a one-sided probe, or do you have something running in some of these SaaS providers that sort of acts as a receiver for these probes?
So this is one-sided. Yeah. So we've got a software agent here doing the probing. There is some little bit of data set we have about your on-premises gear. So like, we've been monitoring this gear for a while, so we figured we'd go ahead and plug in the data we have. But all of the data on the right-hand side with all of the internet providers and so forth, that's not instrumented in their network.
What about What about perspective? Are you running this all from a single station, or do you have agents that allow you to do this track from anywhere in the network?
So when you deploy, you can do it from anywhere you want where you can deploy an agent, and the agent can run on any Windows box. So it's really up to you.
And you can have agents all over the place, just activating them whenever you need them.
Yep.
Thank you.
When I think about agents, I think my agents are sort of a representative of the user, so I want to place them anywhere where I have big groups of users. So for SolarWinds, we would place them in our Austin office, in our Czech Republic office, in our Lehigh office, all these different places where we've got users.
And is that just software? Is that an application install, or can that be in a VM in Hyper-V?
It's just software, yeah. So you can install it on Windows Physical or VM.
Does it need to be a dedicated box, or just can it go in a box that the user's using?
It can go in the box the user's using if you're going to do a couple of paths. If you want like 20 or 30 paths, we're going to use some resources, so you'll have to be considerate of that. Okay, so we go through our, if I zoom out here, we've got our source on the left. We go through some internal infrastructure. We pop out to the internet. Then we go to, looks like Time Warner Cable Internet, then Time Warner Cable Internet again. If you're familiar with Time Warner, you know they did some mergers and acquisitions with Time Warner Telecom, so you can actually see that in their network infrastructure here. Then over to Telia, Sonera, and finally Salesforce and the servers that provide the connectivity. Make sense? Okay, so one of the interesting things I like to highlight here is Telia, Sonera, we don't have any business relationship with at all, right? We pay Time Warner, this is from our office, so we pay Time Warner for internet, and we pay Salesforce for service on their application, but we pay Telia Sonera nothing. We aren't even aware of them outside of NetPath, right? But despite that being the fact, we depend on them for not only services at the company, but critical services, right? If Salesforce goes down, we can't make money. So that's sort of one of the things that NetPath is trying to bring to the surface to help you troubleshoot. So I'm going to hop out here and jump to, okay, so let's look at this path just a little bit deeper, and then we'll take a look at an example of a problem, okay? So on the left-hand side, we can see that this is our infrastructure, and we've got a little bit of multipath going on here. So some of the connectivity some of the user traffic is going through the top and some's going through the bottom. If we mouse over, we can see about 67% of our traffic is going through that top link and about 34% going through the bottom link. We've also got in performance not only for the end-to-end path, but for each component of the path. And this is really important to understand the relationship of all of these different pieces that build the end-to-end performance that your user experiences. So we've sort of got that listed out in labels. My favorite thing since I last showed you guys this is that there's labels now. Before it was all just a circle and I had to mouse over anything to see what it was, which was really confusing to present on. We also stick in the middle here an icon for the role of the entity. And if you click, you can identify what it is, what you call it in monitoring. You can actually click over and get the rest of your monitoring data about that. So we'll look at the internal data set a little bit more later. As we move out here through to the internet, we can see this is the first internet node. It's owned by Time Warner Telecom. We are announcing it at SolarWinds with our AS20251. We connect over to Time Warner, and you can actually pop these out as well and sort of see Time Warner Cable's network there. Their AS11427 is comprised of these 5 nodes as it applies to our path, right? These are the nodes we use in our path. And it goes over to this other chunk of their network where they've got sort of more heavy multipath to Telia Sonera. Telia Sonera's got quite a bit going on. And finally to Salesforce. Okay, and if you look closely, you can see there's slightly different performance on all of these links, right? This is less than a millisecond, this is 8, this is 19, this is 39, right? So when you're thinking about the end-to-end performance, like each one of these, the user will take any of these paths and they refresh the browser, they may take another path. So you want to be aware of all of these things. In Salesforce's own network, they've got a little bit of routing infrastructure, and we can see a chunk of our data going to this top and a chunk going to the bottom. Okay, so that's sort of the end-to-end view. I'm going to collapse these networks back down so we can have the simplified view.
Chris, that data that you're showing us, that lives in my SolarWinds infrastructure. That's the only place it lives. It doesn't
That's
live.
absolutely right. This is in SQL,
Okay.
the SQL instance for SolarWinds.
There's no data that ever gets rolled up into the cloud or that SolarWinds can see as an aggregate from other customers?
Not unless you opt in. So we have an Orion improvement program, much like Microsoft or any application where it says, would you like to give statistics so that we can make the application better? We have that, but otherwise, no.
So no crowdsourcing.
That's right, but we will be talking about that.
Can you toggle the display? I noticed that the pop-ups show packet loss. If I want to see that along the links, can I change the view?
You cannot. So how it displays right now is we display latency all the time and packet loss when there is packet loss. Okay, so we'll add it as another label. Actually, maybe I spoke too soon. So we're looking at the most detailed view now. There's sort of different levels of aggregation that you can do by clicking on these different details. This looks closer to our original demo that we did for you guys. So depending on really how complex your path is, you can sort of simplify that. Okay, so looking at this,
how are you measuring this? Are you doing a trace route? Or are you doing ping?
So we are sending active probe traffic. It's all proprietary. We craft our own packets, but fortunately, we just got to patent pending. So I'm going to be going through some of the specifics of how we do that later on in the presentation.
Are you toggling ports to determine alternative equal cost paths or anything like that?
We do a number of things to make sure that we can discover all of the paths, including toggling ports. Yep, indeed.
A question that just came in on the NFT13 hashtag from Matt Vault. Is there programmatic access to the path data that you're collecting? Are there APIs or anything like that?
That's a great question, and fortunately, when I was presenting to you guys before, you were like, we need API access, so we now have that. In our 1.0 version, we included access via API with SWIS, what we call our SolarWinds Information Service. Get all this data. Okay, all right, so we've seen sort of what the picture looks like, how you can look at a path when there's no problem. Let's take a look at an example of when a problem occurs. So I'm going to jump back out here. Take a look at Salesforce. Okay, so we're a network engineer in this scenario. We're sitting at our desk. Someone comes by and says, hey, we're having some problems. Salesforce seems to be slow. It started around 7:30, 7:45, something like that. So we go to our NetPath screen here, and we go to the Austin Lab probe, or whatever probe you have close to that user base. And you'll notice across the bottom here, now that I've sort of taken away the full screen, we have this graph. So this graph represents the end-to-end performance. All of the data up top is aggregated together to tell you when a user opens their browser and goes to salesforce.com on port 80, what's the latency, what's the packet loss. There's sort of a couple of metrics we can look at there. So we notice across the bottom through all of last night and this morning, we're sitting around 60, 70, 100 milliseconds. So not super consistent, but consistent enough. That's all pretty reasonable. And then once we got to 7:50 a.m., that seemed to be going up here. So now we were 115, now we're at 252, 301. So a new latency of 140 to 180. Let's say. Now the cool thing is we've got lots of graphs in SolarWinds, but the cool thing about this graph is it's also your navigation function. So if you want to know what was going on that caused that end-to-end latency, we click the graph there, and it will load for us the network path at that time. So this is sort of the complete explanation of why was it 301 milliseconds. And we can see right off the bat it's also trying to identify where the problem was specifically. So if we sort of run through all the red here, we can see that this top server here, it was taking some 51% of our traffic. Through all the load balancing, 51% of our traffic got to this top node. And if we click into it, we can see average latency of 280 milliseconds. We look at the bottom, he's at 322. He's taking around 50% as well. So definitely a problem for transit to both of those. Now, all of this looks green, right? So I'm going to zoom in on the red part, right? And we'll notice that there's 234 milliseconds between R3 and R5. So that seems like a lot. When you're troubleshooting, comparison is super, super powerful, right? Like we did it this morning. Someone said, I can't connect to the wireless. And I was like, well, I can. So now we know it's a problem on that specific device, right? So in the sake of comparison, or cheating with comparison, we'll look at the interval right before the problem occurred. And it will load that path and sort of try and keep the graph in the same place here. And we'll see that between R3 and R5, we had 3 milliseconds. So then at the peak of the problem, again, 234 milliseconds. So definitely appears like the problem is between R3 and R5. There's no packet loss though. We've got about 67% of our traffic going across that top link. Now once NetPath identifies where the performance impacting problem is occurring, then it will pull in extra data that we may have, whether it's from internet repositories or our own data set because you're monitoring with one of our tools, right? So in this case, it's telling us, hey, there was a configuration change on this node. What that means is where the performance problem happened, there is a configuration change that happened around the same time as the performance impact started. That's the correlation there. And if you click on that, you can see a little bit of time of exactly when that occurred. If you click on that, it'll go ahead and do a diff for you and answer the question, okay, so what was the configuration change? And as we scroll through here, it will highlight for us, okay, so something going on here. It looks like that line was changed. Anyone see a problem here? This diff? Anyone?
Zeros. Missing a few.
There is an extra 0. Okay, so that's one of those things that like I'm guilty of as well. It's really easy to lose track of zeros. So this one was 10 megabit per second traffic shaper, and this is a megabit per second. So even though the interface isn't capped out, we are now queuing packets. We now could be throwing away packets if we're queuing them for too long and so forth. Now this is a change on Ethernet 1.0, and it looks like that was the only change. So now that we have that data, Ethernet 1.0, traffic shaping is an egress function. So we'll take a look at this link. We actually do map that to specific interfaces. So here it is in fact Ethernet 1.0 that this path is coming in across the top. R3 is connected to Ethernet 1.0 on R5. Okay. Now this is a egress function. So I'm going to go ahead and switch over to egress for top 3 conversations. Like the next question I have is what data is that, right? So traditionally I get that from NetFlow. So we've got that conversation set built in here. And I'll go ahead and select egress since traffic shaping is an egress function. Then we can immediately see, and we'll get that out of the way. We can immediately see the specific conversations that are taking up that now 1 megabit per second. And clicking into that will drill on over to that conversation, or it's not enabled in the online demo. But clicking into that in your production environment will drill down into that specific network conversation in our NetFlow tool. So very quickly, I'd like to point out a couple of things here. First is the analysis we're doing is very, in the presentation that we have, is very focused on the user's performance to the application. Whether the user is really a user or whether it's a server that uses another server. So for example, a web server uses a database server. It ends up being a user of that server. But it's very focused on that user to server interaction and the delivery of that. And we have a huge amount of data we could put in here. We tried that. It looked like a mess. It looked like a bag of Skittles with all the colors we were using. But we focused on what is the performance impacting thing here. So then we've just got red in one spot, and when you click in, you have the data you need to sort of analyze further. And only when we find red do we tell you there's a configuration change, right? So if there's some configuration change on this device, or the router's CPU is at 99% on this device, if that's not affecting your transit performance, we will not show it as red. So it really is focused on sort of troubleshooting and understanding that performance.
So your making sure a crime's been committed before you identify suspects.
That's right. That's right. Like over the past decade, we've gotten really good at asking all of the people what they're doing wrong. And we can present to you just tables and tables of data. But sometimes you're like, well, I got a specific problem I'd like to solve without looking through all the tables.
So you're pulling the NCM module, the network configuration module, to get that information about a config change.
Yes.
Typically, the configs are backed up like once a day. Is there a change you need to make within NCM so that way you can get those recent up-to-date configuration changes?
Yeah. So once a day totally works. It just does not work as well because we're not able to do as good time correlation. NCM has a feature called real-time change detection. And so what that amounts to is you configure the router to send a syslog message whenever a configuration is changed. And then whenever we receive that over an NCM, we'll go pull a fresh copy. So then we can get a pretty current version of what's going on all the time. And then the time correlation works better, for sure.
Cool. And how does this work with firewalls?
That's a great question. I've got actually a whole lot of content, but around how that goes together. So we're going to get into that.
Let me ask you, so if a customer's got an enterprise has like a pretty complete deployment of SolarWinds products, right? You might have the IPM unit, and you might have NCM, and you might have NTA, and you've got NPM, right? You've got a lot of data about that customer's network. What kind of integration is NetPath doing with that to determine, oh, this link is red because this card has exceeded XYZ, and you learned that from NPM, or this link is overloaded due to this type of traffic because you can pull that from NTA. Is there anything that you're doing with integration with other?
Yeah, absolutely. So
products there?
what we're looking at here is from NPM, NetPath, which is a feature of NPM. And then this data right here, this config change is pulled in, as he mentioned, by NCM. And when I clicked on the interface and looked at flow, that's data pulled in from NTA.
Okay, so it is, great.
Right now, the primary sources of data on the screen in terms of from other SolarWinds products is NPM, NTA, NCM. Those are the big ones.
Cool.
Now, this is a one-way path. I don't see how you could possibly get two-way path with stuff out on the internet, but sometimes you have asymmetric paths where the problem could be on the return path.
That's absolutely true. Right now, this is for symmetrical paths. Something we're thinking about. It's hard. We'll see what we can do there.
Is there any consideration being made for remote locations that don't have compute, like containerized agents, that sort of thing?
So we totally want to do that. I don't know how to do that reasonably. When you look at how we do our probing, which we're going to show you, it requires access to be able to a packet driver to write your own packets, and that's sometimes not available in Cisco's containerized solution for their ISRs or something like this. So, or we would have to write from scratch. So something we're thinking about. I'd be curious to hear if you guys, as you see it, if you guys think of specific locations where you don't have compute, what other physical assets you have there that you'd like to see it run on as a source.
Be interesting to see it on like a Raspberry Pi or something that's easy to deploy.
Totally would, wouldn't it? I totally want to do that.
Or even as a a cloud module that you could stick in Azure, EC2 or.
So you can do that now because it can be on a Windows VM, but it requires a little bit of work for sure.
Yeah.
I know you said there's agents to put on a Windows VM. Is there any application awareness, or is it just monitoring the network?
It is monitoring the network. It is monitoring the network. We do a lot of application stuff. Sort of, I have peers on the application side and system side, and we're thinking about how to pull that picture together. But I don't have anything to share on that right now.